Lesson 9.2, we are going to work on simplifying radicals. So if you remember, what we did on Friday when we did lesson 9.1 is we simplified square roots, or radical. This is our square root sign, which is also known as a radicand, okay? So if I had the square root of 9, Brianna, what would my answer be? 3, and what does that 3 have to have? Positive and negative, okay? So for those of you who are not here on Friday, what you have to have in your answer is a positive and negative sign, because 3 is the square root of 9, because 3 times 3 is 9, but also negative 3 is the square root of 9, because negative 3 times negative 3 is positive 9, okay? So you always want to have that answer. Can I ever have a negative sign underneath the square root? No, there is no such thing as a square root of a negative number. So this would be none, or no square roots. There's nothing I can do, okay? So if you also remember on Friday, when we had a certain number that did not have an exact square root, let's take 8 for instance. If I had the square root of 8, is there any number at all that will go into 8 that I can multiply with itself? No. So what we did on Friday is we plugged that in and we rounded our number to the nearest hundred. So we got a decimal. But what we're going to be doing today is, if you remember, most of your calculators wrote your answer like that. And that's what we called a simplified radical. And that's what we're going to be learning to do today, okay? Again, you just heard me say, if I plug this in my calculator, it will give me this answer, which guess what? This is your final answer. However, you will have to show work when getting this answer, okay? If you write this as your final answer and there is no work shown, you will receive no credit, all right? Is that clear to everyone? So let's go ahead and get started then. So what I do is I simplify radicals whenever I know there is not an exact square root, okay? You say, okay, what do you mean by exact square root? Well, we know the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. So each of those numbers have an exact square root. We can keep going down the list, all right? But 50, if I ask myself, what numbers multiply to give me 50? Are there any of them that multiplies the exact same number to give me 50? No. So this is how we simplify, because I no longer want your answer in a decimal. That's what we did on Friday, but now I'm teaching you to simplify radicals, which is what I want your answer as, okay? This is what we're going to do. We're going to do what we call upside down division. Upside down division. And it looks exactly like what its name is. What I do is I take the number underneath the radical, which is 50, and I write an upside down division sign. So go ahead and write that. And then I just divide. I ask myself, what is the smallest prime number? Prime means a number that can only be multiplied by 1 in itself. That goes into 50. Who knows what that is? 2. Think smaller. Think the absolute smallest, okay? So 2 goes into 50, and I do 50 divided by 2, which is 25, and I just write that right underneath it. Then I ask myself, what's the smallest number that will go into 25? 5. So I do another upside down division sign, write 5 here, and then I say 25 divided by 5 is 5. Now, whenever you get a prime number, you stop, because there's nothing that will go into 5 but 1 in itself, and you can't keep going after that. So this is where I stop, and I say, okay, you look for a pair. A pair is 2 of the same number. Do I have a pair here? Yeah. 5 and 5. So what you can do, whenever you have a pair, I take 1 5 out. I do not multiply them together to get 25. I take 1 5 out, and it gets to go on the outside of the radical, or the radicand. Okay, it goes outside of the square root. Now, whatever you have left, 2, it does not have a pair. It cannot be combined with anything. So whatever numbers do not have a pair, go back underneath the square root symbol. And that is my simplified answer. But what is the one other thing I need? We learned about it on Friday. Positive, negative. Okay. Now, you say, what if, this is just hypothetical, what if I would have got, let's say, another 3 here? Does 3 have a pair? No. So that means if you have 2 numbers without pairs, I multiply them together. 2 times 3 is 6, and 6 would go underneath. Same thing as if I had more than one pair. Let's say that there was 2 3s. I would bring out a 3, and then I just multiply those numbers together. 5 times 3 is 15 times the square root of 2. Okay? Okay, so let's do 48. Now, if you look, does 48 have an exact square root? Nope, it does not. Okay? So I say, can 48 be simplified? Yes, it can. So I need to do upside down division. Upside down division. So I start with 48, and I ask myself, what is the smallest prime number that will go into 48? 2. 48 divided by 2 is 24, and I put that there. What's the smallest number that will go into 24? 2. Gives me 12. What's the smallest number that will go into 12? 2 gives me 6. What's the smallest number that will go into 6? 2, which gives me 3. So let's circle pairs. I have a pair of 2s and a pair of 2s. So that means out of each pair, how many 2s do I pull out? 1. So what happens when I have to pull out 2 2s? What do I do to them? Multiply. So I get 4 on the outside. And what is left to go back underneath the radical? 3. 3's all by itself here. And you want to make sure your answer is positive, negative. Now, let me be clear. If you plug in your calculator, you will get this as your answer. If you do not show this work right here, you will receive no credit at all. No credit at all, because all I know is you plugged in your calculator and your calculator did all the work. You did not show me one bit that you know how to do the work. Okay? Now, let's look at this next problem. What I have is I have 2 radicals. Neither one of them have an exact square root. Square root of 2 does not have an exact square root. Square root of 8 does not have an exact square root. But they are what we would consider like terms. The reason why they're like terms is because they both have the radicand or the square root symbol. So what I can do is I can say, okay, since they're both a square root, I keep my square root sign and just multiply the numbers. What's 2 times 8? 16. Can I simplify the square root of 16? What's the square root of 16? 4. Positive, negative, and that's my answer. Okay? Now, if this were your problem, 2 times the square root of 8, I cannot do the same thing because they're not like terms. It would just be like me giving you 2 times x. You can't multiply those together, so what would you do? You write them side by side. Same exact thing, you write them side by side. Because this is read 2 times the square root of 8. Okay? Example 2. So what we have is fractions here. Okay? And don't look at this and think, oh, this is going to be too hard. I don't like fractions. Okay? It's actually very simple because we break it down. Anytime you have a square root symbol over a fraction, all that means is I have the square root of 7 over the square root of 16. Look at it as 2 separate problems. First of all, ask yourself, can I simplify the square root of 7? No, if I tried upside down division, I wouldn't be able to divide anything because 7's a prime number. Do not make it a decimal. If you cannot simplify a radical, guess what? It stays a radical. There's nothing you can do to it. Do not make it a decimal. If you do, your answer is wrong. Now let's look at the denominator. Do I have a square root of 16, which is 4? Can I divide the square root of 7 and 4? Nope. Number 1, they're not even divisible. Number 2, they're not like terms. So even if they were, I could not divide them. So I have my positive, negative. Square it in. That's your answer. Okay. Let's do the next one. Again, break it into 2 problems. The square root of 1 over the square root of 4. Does 1 have an exact square root? 1. Because 1 times 1 is 1. So guess what? The square root of 1 is 1. What's the square root of 4? 2. Positive, negative. There's my answer. Okay, now let's look at this next problem. Look underneath your radical. They're both like terms because they have the square root sign over both of them. Can I do 10 divided by 2? What's 10 divided by 2? 5. So I keep my radical because they're like terms. 10 divided by 2 is 5. Can I simplify the square root of 5? Nope. So I have positive, negative, 5. And this last one here. Can I do the square root of 18 divided by 3? No, I cannot because they're not like terms, okay? If this had a square root symbol, yes, absolutely. Your answer would be the square root of 6. But it does not. So you say, okay, what can I do? All right, what can you do? Does 18 have an exact square root? No. But can it be simplified? Yes. So I need to do upside down division. So do 18. What's the smallest number that can go into 18? 2. 18 divided by 2 is 9. What's the smallest number that will go into 9? 3. Now I'm left with a 3. Can I go any farther? Nope. Let's look for a pair. Austin, what would my pair be? 3. So how many 3's do I take on the outside? 1. What goes back underneath the radical? 2. And I can't forget about my denominator because it's still there. What am I going to do now? Can I simplify this even farther? Yep. 3 over 3 can cancel out. Or if I divide them, what does it give me? 1. So that's the same thing. When you get a 1, it's the same thing as canceling out. So my answer is positive, negative, square root of 2. Okay? Now, if you wanted to, you could write a 1 there, but you don't have to. Any questions? Okay, so here we go. This is our last example. Okay, I'm going to read this to you so you better understand what's happening. Okay? In this first problem, this is how this problem would be read. 2 times the square root of 3 over 4. So what type of problem do I have? Multiplication. So the easiest thing for me to tell you to do is go ahead and make this 2 out in front a fraction, because then it'll be easier to see. So that as a fraction would be 2 over 1 times, let's break it down into 2 problems, the square root of 3 over the square root of 4. Now I just want to multiply. And remember with fractions, you multiply straight across. Are these like terms here? No. It would be like me asking you to multiply 2 times x. So how would I write this if I can't multiply and get the square root of 6? What would I do? 2 times the square root of 3. You just write them side by side. Now, is there anything I can simplify before I multiply in the bottom? What's the square root of 4, Marcus? 2. 1 times 2 is 2. Can I simplify this even farther? Yes. Yep. Cancel out my 2's. And what's my final answer? Positive, negative, square root of 3. Okay, let's look at this next problem. Negative 2 times the square root of 27 times the square root of 3. Dalton, what are my like terms in this problem?
27.
Exactly. So guess what I can do? I'm going to keep this negative 2 exactly where it is, and I'm just going to multiply my like terms. What's 27 times 3? 81. So now I have negative 2 times the square root of 81. What's the square root of 81? 9. So now I have negative 2 times 9, which is negative 18. Now, obviously, you don't need your positive negative because your answer is negative 18. It's not positive negative, negative 18. Okay? So does everybody see how you can combine those like terms and then simplify? Now, let's look at this next problem. Your first instinct here may go, oh, I can do 10 divided by 5. But you cannot. You cannot. The reason why is because if you divide one of the numerators by 5, you have to divide the other. Can 16 go into 5? No, it cannot, okay? So let's go ahead and do what we can. What do you think we would do first? Asia? Multiply 10 and 16 because they're like terms. So I keep my square root. 10 times 16 is 160 divided by the square root of 5. Now can I divide? Yes. Does everybody see how it pays to wait? What's the square, or what's 160 divided by 5? The square root of 32. Now, is this my answer? Nope, because it can be simplified. So do upside down division. What's the smallest number that can go into 32? 2. I get 16. Smallest number that can go into 16? 2, which is 4. Smallest number that can go into 2? 2. Oh, wait, I'm sorry. I messed up. 16 divided by 2 is 8. Smallest number that can go into 8 is 2. I'm left with a 4, 2, and 2. That makes a little more sense. Now, let's circle my pairs. I've got a pair of 2's here and a pair of 2's here. So what am I going to pull to the outside, Brianna? There. And then, because I get 1, 2 from here, and then what about here? I get 1, 2 from there. So what is 2 times 2? 4. 4 goes to the outside, and what stays underneath? 2, because I have this 2 here left all by itself. Positive, negative is my answer. Now, there's one other type of problem that I want to show you that you do have one like it on your homework, so I want to go ahead and go over it so you know how to do it when you get to it. This isn't the exact problem, but it's something very similar. What if I had 1/2 times the square root of 8? Write this down. I want everybody to write this one down. What could I do first on this problem? Asia? Okay, I can do 8 over 1. But what am I really going to have to do? Upside down division for 8. Okay? And I'll show you why you don't necessarily have to make that a fraction. Okay? Let's do upside down division of 8. 2 can go into 8. I'm left with a 4 and a 2 and then a 2. So I have a pair of 2's that I can bring out. But what's already on the outside? 1/2. So if I do 1/2, I'm going to multiply it with the other number that gets taken out. 1/2 times 2 is 1. And what am I left to go back underneath this square root sign? 2. So there is your final answer. Do you see why now you don't really need to make it a fraction? It'll simplify itself. Okay?